Elastic Grid Service and its ability to do workload placement across a diverse set of clusters and GPUs. As a quick reminder, Elastic Grid Service manages your fleet of GPUs. We have a dashboard that shows how many GPUs you have in your system, what's their current level of utilization, and a bunch of other useful details about GPUs. But for today, we're going to go straight to looking at how we distribute workloads across clusters. You can see that we've set up an environment where we have a far edge, a near edge, and an AI factory. This might be a common deployment pattern as we see AI being distributed to deeper in the networks and needing to deploy workloads at diverse locations. Within these clusters, each cluster has GPU resource. You can see that the far edge has a smaller GPU at RTX 4000. The near edge has a little bit bigger one at L40S, and the AI factory has an H100. So again, to mimic those different inferencing tiers that you may see distributed in the network. What you'll also notice is that two of these are allocated already. So the far edge is allocated and the AI factory is allocated, but there's some capacity available at the near edge. We mark available as red to show that here's an opportunity wasted to monetize this capacity or to utilize this capacity and put it to work rather than it just sitting there collecting dust. So we're going to show you how you do that. Through our workspace concept, we have a number of workspaces, but for this demo, we're going to talk about the tiered inference workspace. And if we look into this one, we can see that it has a couple of clusters. Indeed, actually all the clusters are part of this workspace, meaning that when we deploy workloads into this workspace, the system will automatically decide which of the clusters, which of the tiers to deploy the workload. And that's based on policy and availability of resources. The other thing you'll notice is each workspace has a policy. So our tiered inference policy allows us to use any of the GPUs in the system. It allows us to use up to 79 GB of GPU memory and allows us to run high priority jobs and jobs for a long time. But these policies are all very configurable for each workspace individual. Now, to actually see the workloads that are currently running, we can look in a couple of places, but we're going to look in the AI workload section to show that in the tiered inference workspace, there's currently one instance of a Llama 3 model running, and that's been running for a little while. It's running about 77% GPU utilization. We can also see the other workload that was taking up the other GPU was a batch job. We just have a stress test running the GPUs flat out at 100%. So we see those show up on the dashboard in terms of the utilization of the system. There's our H100 running flat out, our RTX 4000 running about 80%. Now, what you might notice is as this inferencing, this far edge inferencing is filling up, you may want to scale this deployment and get some additional capacity there. The good news is Elastic Grid Service has a built-in scaler that will automatically detect when you're approaching capacity and create additional instances of those LLMs, and then do the automatic load balancing. I'll show you a quick diagram of what that looks like. This is representative of our two clusters, the far edge and the near edge. And you can see our multi-tier inference workspace spanned across these two clusters. Now, for simplicity, I didn't show the AI factory, but it's also part of this, this workspace. Now, as the VLLM pod, which we're running VLLM, is receiving traffic, it'll get to a certain capacity. When it reaches that capacity, it'll try to spin up another pod. This is standard Kubernetes behavior if you are familiar with HPA or CADA. As that additional pod tries to come up, however, we know this far edge cluster, as you can see over in the inventory, doesn't have any more GPUs available. They're all allocated. So that's not going to be an option. So instead, what the system, what our grid service does, is detects and recognizes that region 2, or the near edge, has another GPU available for use. We will actually relocate this pod from the far edge to the near edge, launch the pod, and continue to provide inference requests to now both of these pods through a load balancing. That load balancing rides over our overlay network. We call it Cube Slice. This overlay network is connected over a WireGuard VPN, so it's very high performance and also very secure. So you don't have to worry about your data being exposed on the public internet. This is all east-west traffic. All right, so let's see this in action. So going back, we have an available near-edge GPU, and we have jobs running on the far edge. Now, normally we'd let our scalers scale it up, but I'm just going to do it by increasing our replicas. This is our VLLM deployment, and I'm just going to change the replicas to 2. And so now if we look at the pods, you're going to see that there was one VLLM running. Now there's another one that's trying to run, but the scheduling is gated. It can't actually run because we know there's no more GPUs available in this cluster. So what's going to happen to that one? Well, let's go look at our GPU request queue and see what's up. We can look in here, we can see that the tiered inference on the far edge is already provisioned, and that one's running quite well. Now we see that there's a new request here for tiered inference on the near edge. So again, we recognized that there was capacity on this L40S. We seized that capacity, and I'll actually scroll to the very end of this list and show you, here was the request for that extra far edge inferencing pod that couldn't launch, and we've relocated that request. So that's how the system moves the workload from one tier to another. If we refresh this, we should see that near edge is now provisioned. And if we go over to our near edge cluster and look at the pods, we'll see that there's actually a new Llama deployment happening over in this cluster. Again, no user interaction other than the scaling, which is also can be automated. And a new deployment spun up, and we'll begin getting traffic and load balancing those LLM requests. Our inventory now reflects that all of the machines are allocated, so they're all being utilized for different jobs, and our dashboard also reflects the same. So thanks for seeing our workload placement demo.